Video, we're going to review some important concepts about linear functions. Every linear function has a constant slope, so it's going up or down at a constant rate, and that slope is often represented by a letter m. We also look at the y-intercept of the linear function. That y-intercept is often represented by the letter b. And we'll see how we write the equation of a line in just a little bit. But we're going to start by looking at the slope of a line. For the slope, we need to find 2 points on that line, and then we're going to look at how much does it change in the y values and change in the x values. This is often represented by the rise over the run. So for this function, we rise 1 and run 2. So it has a positive slope. We see a positive increase of 1/2. It's going to rise 1 for every 2 in the x values. That gives us our slope formula that you might be familiar with. In this, we have the change in y over the change in x. Now, I used a Greek letter delta here that is often used to describe the change in something. So this is the change in y over the change in x. We are looking at how much do the y values change versus the x values. So you often have seen this formula broken down into y2 minus y1 over x2 minus x1. That is still finding the rise over the run. So we pick a point and label it x1, y1, and pick another point and label it x2, y2, and then we calculate the slope between them. So in this next linear function, we have 2 points, and you could label them x1, y1, and x2, y2, and then use that same formula. Or you can do this graphically with rise over run. What we do want to pay attention to is the scale of our axes. So these are counting by ones, and we can see that the y values are decreasing by 3, and the x values increase by 4. So the slope of this one would have a slope of -3/4, -3/4. We could have used the slope formula for that and done y2 minus y1 over x2 minus x1, and we'll get the same thing. For this one, y2 I have labeled as 4 here, minus y1, which would be 7, over x2 minus x1, so 4 minus 0, and we do get -3/4. So we're going to find the slope of the line that goes through these sets of points. All right, often I find this helpful to write it as a table just to organize my x and y's, but that's not necessary. I do have 4, 5, and 6, 2, and we can look to see how much does it change in the y values. The y values decrease by 3, and the x values increase by 2. So if I'm looking at change in y over change in x, that would have been -3/2. So the slope is -3/2. If I look at the second one and organize that one in a table format, I have 3, 8, and 7, 3. We can see that the y values went down 5, and the x values went up 4. So if I find the change in y over change in x, that slope would be -5/4. And then for the next one, we have -2, 7, and +2, 7. Here, the y values are not increasing at all, so that we have an increase of 0. But the x values did increase by 4. So the slope of this one change in y over change in x. The y change is 0, so that would become 0 over 4, but 0 over 4 is just 0. So that has a slope of 0. And the last one, 9, -1, and 5, -1, we can see that the y values change by 0 again, and the x values change by -4. So slope is 0 over -4 is still equal to 0. Now, what if we had swapped those? In fact, I think I intentionally meant to put this as -1, 9 and -1, 5, because if we look at that change in y, change in x, we see that the y values decreased by 4 and the x values didn't change at all. If we use that slope, we would have -4 over 0, and we cannot divide by 0. So we have an undefined slope. That undefined slope is happening because we have a vertical line in this one. If I was to graph those points, we would have -1, 5, which would be somewhere here, and -1, 9, a little bit above it. But the slope between these is showing a vertical line, and that has an undefined slope. Now, to write the equation of a line, we typically have 3 different forms that we talk about with linear functions. One of the most popular ones is slope-intercept form, and we will use that pretty often when we talk about linear functions. There's point-slope form as well. This deals with transformations a little bit, so when we get to the transformations of functions in our course, this might be more helpful. And then there's standard form equation, ax plus by equals c. In this form, the x and y are on the same side, and they're represented with coefficients that are integers, not fractions or decimals. So if we focus on slope-intercept form, y equals mx plus b, that m is our slope and b is our y-intercept. We can go from a graph and identify those 2 important features. So here I can see a y-intercept of 3. So the y-intercept crosses the y-axis at 0, 3. And we can find the slope by picking any 2 points on this line. I can use the y-intercept as one of those points and find that we went down 2, so -2, and right 1, +1. If you want to find other points, you're going to see that same slope is constant. It's going to continually go down to right 1, down to right 1. So it has a slope of -2. Using these 2 things, if I put this in y equals mx plus b, where we have our slope and our y-intercept, we would write a function of y equals -2x plus 3. For this second graph here, in number 6, we can see a y-intercept of -1, and then we need to find the slope. We don't really want to estimate points if we can prevent that. So we're going to find nice points, and there is one at 3, 1. We could have also used this one over here at -3, -3. Either way, we see a positive slope happening, and if I pick 2 points, I can find the rise over run. This went up 2, right 3. So if I find the slope, that would make that 2/3. Remember, we're doing change in y over change in x, so a +2 over 3. This would make my function y equals 2/3 x minus 1, That y-intercept was -1. We can continue this without a graph. So if I know there are 2 points on the line, there has to be a unique equation that goes through those 2 points. To do that, we first want to find the slope. So we want to find the slope between these 2 points. I'm going to use that slope formula that we had, y2 minus y1 over x2 minus x1. And we get 9 over 3, which is a positive 3 slope. Now, the equation would have a slope of 3, but we do not know what the y-intercept is because neither one of these points is the y-intercept. We need to figure out what is the y-intercept that fits for these 2 points. And we can do that by plugging in one of the points. It doesn't matter which coordinates you use because both of them are a collection of x and y. So whether we used x1, y1, or x2, y2, they both represent a relationship between x and y. So I'm going to use that first point, -1, -4. That means y is -4 when x is -1. But we still don't know what the y-intercept is, and we're going to solve for the b, the y-intercept, that would satisfy this relationship. So I just solved the rest of that equation. That would give me -4 equals -3 plus b. We can add 3 over and get -1. So the equation for this would say 3x minus 1. The slope was 3 and the y-intercept is -1. For 8, we have 2 points, 4, 5, and 5, 3. Again, we need to find the slope first, and that's the change in y over change in x. If you like doing this as a table, I find some students really do prefer that format. You can write that 4, 5, and 5, 3, and see that the y values changed by -2, and the x values changed by +1. So we have a slope of -2 over 1, which is just -2. To find the y-intercept, we're plugging in that slope. We know that the equation would have a slope of -2, but we don't know what the y-intercept is. That's still an unknown. So we can find the y-intercept by plugging in one of those points. I used the first point last time, but it doesn't matter which point we use, so I'm going to use the second point this time. That point is an x, y coordinate, so it's saying that when x is 5, y has to be 3. We're going to substitute those values in, and then we will solve for b. All right, and to solve for b, we would do 2 times -2 times 5 first, so 3 equals -10 plus b. And we add 10 over to get 13 equals b. So the y-intercept is 13. Our equation would say -2x plus 13. We could write this from a table of some sort. What we want to verify is that we do have a constant slope. This one, if I see change in y, this is a change of -3 from 15 to 12. And the x's changed from 0 to 2, so that was an increase of 2. This is a constant change. We keep going down 3 for every 2 in my x's. So there is a linear relationship happening here. A linear function just has to have a constant rate of change. So if we find the slope, we have change in y over change in x. The rise over run, that would make this a change of -3 over 2. You do want to make sure that you're putting your y change on top. And then we can find the y-intercept. Well, luckily I can see that one in this table. So it has a y-intercept of 0, 15. The coordinate is 0, 15. And then we can put those things together to write the equation. So this equation would be y equals negative 3 over 2 x plus 15. All right, we have one more table here. It is also a linear function. We can see that this y is changing by 5, so we have to see an increase of 5 for every 10 increase in the x's. And we want to just verify that's constant. So all of these y's are increasing by 5 for every 10 of x change, plus 5 for every 10. So we do have a constant rate of change. That slope is 5 over 10, which reduces to 1/2. However, we don't see the y-intercept automatically. And we could find the y-intercept two ways. We could do what we just did. We know that the y-intercept would have to be some value that satisfies this table. So we could plug in a point and solve for b, like 10, 35. When x is 10, y has to be 35. And then that would be 35 equals 5 plus b. Subtract 5, we get b is 30. However, if you can find the relationship in this, we could also go backwards 10 to 0 and go backwards 5 to 30. So we know that 0, 30 would also be a coordinate on there. However, either way, we found the slope and the y-intercept, so the equation is 1/2 x plus 30. And then lastly, we have this scenario. So a candle that's 8 inches tall is lit, and it starts to burn and melt. Each hour, the candle melts 1/2 an inch. So we could fill out a table to kind of represent the relationships that are happening. After 0 hours of burning, the candle started out at 8 inches tall. And then after 1, we're going to reach 7.5 inches, 7.5. After another hour, each hour it will melt 1/2 an inch. So it's going to melt another 1/2 an inch down to 7, and then down to 6.5, and then down to 6. So if we're looking at the slope, that rate of change is going down 1/2 an inch, so minus 1/2 or minus 0.5 for every 1 hour. This would be an equation of negative 1/2 x plus 8. So we started out with a y-intercept of 8, and the rate of change, that slope, is negative 1/2. We can describe what these things represent. So in this case, if I was writing a written description, the rate of change shows that the candle's height, since that's what the y value is representing, is decreasing at a constant rate. It's decreasing at a constant rate of 1/2 inch per hour. And then the y-intercept was 0, 8. That means at hour 0, the height is 8. So the candle's initial height was 8 inches. So whether you're given a graph, some scenario, a table, or just even 2 points, we should be able to calculate the linear equation between those. So lastly, we want to talk about some special linear functions because we do have graphs that are just a horizontal line or a vertical line. In the horizontal lines, we're going to see a slope of 0 because the rise increase is 0 and it is forever running. So if I did rise over run and pick 2 points, I'm going to see a rise of 0 over 1 or over a number. The vertical line has an undefined slope because that's when we were dividing by 0 like we saw earlier. So to graph those, we're going to see either an x equals or y equals equation. So let's start with it y equals. If I see something like y equals 7, that has a slope of 0, and it's saying that the y is constantly 7. So I think about where the y's are 7. Here's a point at 0, 7, but there's also a point at 1, 7, 2, 7, 3, 7, and the y value is constantly 7. The x value might change, but y is still always 7 here. So that's a horizontal line at 7, and it's going through 7 on your y-axis. So that's your hint. It should go through 7 on the y-axis. And we just have a horizontal line there. If I have x, if I have an x equals a number, like x equals 5, then the x value is constantly 5. So I'm going to find 5 on the x-axis and draw a vertical line here. Let's see if I can draw a better vertical line. All right. Maybe not perfect, but it is going through x equals 5. It's 5 on the x-axis. Every point on this line has an x value of 5. So that point here is 5, 0. The point above it is 5, 1, 5, 2, 5, 3, but the x's are constantly 5. So we could do another one. Let's say I have y equals -4. That's going to go through the y-axis at -4. It's a horizontal line because it is a y equals. Every point on this line is going to have a y value of -4. And then one more, let's do x equals -1. You're going to find your x-axis and -1 on the x-axis. Then you can draw your vertical line through -1. Every point on that line is going to have a x value of -1.